Good morning. This is second session of Unit 2, Special Types of Concrete, in which we will discuss about ready-mix concrete. Ready-mix concrete is ready to use with predetermined mixture of cement, sand, aggregate and water. If needed, admixture is also added. RMC is first introduced in Germany by an architect, Jürgen Heinrich Magens. In 1903, he got a patent on RMC. In 1907, he discovered that the available time for transportation could be prolonged, not only by cooling fresh concrete but also by vibrating it during transportation. The first concrete mixer of site is delivered in United States of America in 1913, just before the First World War. The first concept of transist mixer was also born in 1926 in United States of America. In later 1939, the first RMC plant was established in United Kingdom, England. Between the 50s and 80s, in these 30 years, the growth of RMC took place all over the world. In India, RMC was first used in 1950 during the Bakranangal Dam and Koyna Dam. The important advantages of RMC is a centralized concrete batching plant can serve a wide area. The trucks or tankers can reach the remote area also. The plants are located in areas zoned for industrial use, but they deliver in truck and tankers for all residential and inner cities wherever it requires. Better quality concrete is produced with higher compression strength with less water cement ratio. Elimination of storage place in site is avoided as ready-made concrete is available. It eliminates the procurement and hiring of plants, machineries and materials. Wastage of basic material is avoided with a mix truck. There is a less wastage and washout. This is better for environment also. Labor associated with production, transportation, placing is very less as compared to normal mix of concrete. And time required is automatically reduced 50%. Next is reinforced cement concrete. As we know, cement, sand, coarse, aggregate, water, admixtures are used for concrete, which is strong in compression, weak in tension. To increase the tensile strength, reinforcement bars are used in the form of fiber or steel. The reinforcement should be strong, durable, ductile, high tensile strain and coefficient of thermal expansion to reach the stress strain as in concrete. The different types of steel reinforcement used in RCC are mild steel bars, that is cold worked mild steel bar and hot rolled mild steel bar. Next is tar steel or ribbed steel bars, cold worked tar steel bars or hot rolled tar steel bars. They are called high yield deformed bars. Hard drawn steel wires, fabric meshes, rolled steel members like C section, H section, I section, L section, T section, they are readily available in the market. Next, TMT bars and CRS bars. Thermomechanically treated bars, corrosion resistant steel bars. Nowadays they are available in markets. RMC and RCC are both used in structural elements like footings, columns, beams, lintels, chajjas, racks, roofs, steps, parapets, slope drops, and also in multi-stored buildings. Water retaining structures like dam, bridge, retaining walls, abutments, aqueducts, weirs, notches, sluices, canals, channels, water tanks, swimming pools, canal linings, etc. Next, in constructions of pavement, footpaths, roadways, railways, harbour, docks, airport, public buildings, sports ground, stadiums, etc. And it is used in manufacturing of railway sleepers, electrical poles, garden fencing poles, pre-stressed components, chimneys, towers, furnaces, etc. So these are the different types of special concrete which generally we are using. Next, introduction to limit state method design. As per IS Codebook 456/2000, it is the ideal method which contains ultimate strength, serviceability, durability, and safety. Limit states of collapse deals with strength and stability of structure under maximum design load, durability of the structure, and failure of the structure. Limit states of serviceability deals with the deflection and cracking under the service load, that is durability and failure of the structure under the maximum load conditions. We also consider factor of safety for stress in steel 1.15 and factor of safety in stress in concrete 1.5 in limit state design. In this method, it is based on actual stress strain curve of steel and concrete. This method is called non-deterministic method as it is based on the probabilistic approach. This method gives more economical thinner sections as it depends upon the actual data. In this method, partial factor of safety is applied to get the designed values of stress and loads for working condition, that is working load and working stress. Characteristic strength is the strength of the concrete and the value of strength of material below which not more than 5% of the test results are expected to lie. The characteristics load is the load during the life of the structure. The value has 95% probability of not being executed. we are making some assumptions in limit states of design, as in case of simple theory of bending. The plane section normal to the axis remain plane after the bending. That means the deflection is neglected. The maximum strain in outermost compression fiber is 0.0035 in bending. The maximum strain in tensile reinforcement is Fy by 1.15 ES plus 0.002, where Fy is the characteristic strength of steel and ES is the modulus of elasticity of steel. Factor of safety in steel is 1.15 and in concrete is 1.5. Stress strain curve obeys Hooke's law, that is, stress is proportional to strain, and assumed known shapes like rectangular, trapezium, triangle, parabola, etc. to calculate the area. So thus this completes the second unit.